Hello, welcome to another lesson. In today's video we're going to be solving linear equations or systems of linear equations in two variables. Generally those two variables are x and y. And we're going to approach this in two different ways. We're going to graph the lines and see where they cross. That'll give us a solution. And we're also going to use another method called the substitution method. So let's get to it. A set of two linear equations and two variables for which we're looking for a common solution is called a system of linear equations and two variables. So what that means is we're going to be given something in this form where we have a coefficient and a letter and a coefficient and a letter, and we've got two of these, and we basically want to solve for x and y. So at the end of the day, we are solving for x and y. If you have two equations, two unknowns, you can solve that if there's a solution. And what does it mean to have a solution? Well, a solution of the system, is any ordered pair which makes both equations true. So let's just look at a quick example that's kind of tucked in here to see what that means. It says that the ordered pair 7, 4, so when x is 7 and y is 4, is a solution to this system. So for example, if we look at the first equation, if we put in 7 and 4, that gives us 7 plus 4 equals 11. And that's true. Left side is equal to the right side, so we're okay. In the second situation, let's try x and y for that. Well, if x is 7 and y is 4, that gives us 3. And so it turns out that if we solve for x and y, in both cases they will be a solution to this. And that's all it's saying in this case, if you want to read that line. Another way, and probably a more useful way, is to graph those lines and see where they intersect, because that makes it a lot more visual and a lot more easy to understand. So I'm going to pop into Desmos and show you what that looks like. So our first equation that was written on the page was x plus y equals 11. And that line looks like this. There's nothing really special about that line. We could pick it apart, tell us the y-intercept, x-intercept, but that's not the point. I want to put the other line in, which is x minus y equals 3. And now that we have two lines, both lines graphed, the red line and the blue line, or the first line and the second line, where they cross is the solution. That's where those points are equal. And if I click on this, it'll tell me that they cross when x is 7 and y is 4. That's exactly the solution that I found in my notes. X equals 7 and y equals 4. That's the solution to this equation. So in short, the solution to an equation is where the lines cross. You can put it many different ways, but it's where the lines cross, or any ordered pair which makes them true. So you can say it is where the two lines, the technical word is intersect. So it's where they intersect or where they cross. Think of it like you get to a busy intersection in a city or a town. The intersection is where, one road meets another road, and that's our intersection point right there. So what are we going to do? Well, what are we doing going forward? We're going to solve the systems. We're going to find this special ordered pair. All of it is solving for this coordinate xy in 4 different methods. So the first, second, third, and fourth method. Today we're going to be covering methods 1 and 2, the graphing method and the substitution method. That's assuming that the graphing method doesn't take too long. If it takes too long, I'll do the substitution method in another video. But let's just get to it. It says Objective 5211, solve a system of linear equations using the graphing method. And it says right in the method what we're going to do. We're going to graph it. These are, of course, our steps, and let's read them. It says graph both equations on the same axis, and I'm going to say in that case we're going to use any method. Using any method. You can use whatever method you want. I'm probably going to be trying to use the slope-intercept method because I find it easier. Second step, determine the coordinates of the point of intersection of the graphs. So you've got to graph both equations. You need to find the coordinates of the point of intersection. They provide the solution. And then you're going to check the solution. So really the first 2 steps are the most important piece. And remember, the coordinates that you get for the intersection is the solution itself. We can check in the end to make sure that the solution actually works out. So before we actually solve, let's just take a quick look at what are the possible cases. basically, like, if you have two lines, you have three possible things that can happen. They can cross, or they could be perfectly parallel, which means they never cross, or they could be, in this case, on top of each other, which they're always crossing, so we have what's called infinite solutions. So if the lines have different slopes, the name for that is that they're consistent, if that ever comes up. If they have different slopes, they have one solution. So the solution is the ordered pair where the lines meet. And again, the ordered pair here is in the form x, y. The x value and the y value are all wrapped up in that. Sometimes there's no solution. So there's no solution if the lines are parallel. This is called inconsistent, if it ever comes up. And it means that the first line has the exact same slope as the second line. And the idea here is that parallel lines will never cross. So in this case, they have the same slope. Well, there's two things to note. Let's see how I can write it. Note, they have the same slope, which you should be able to tell. They both are parallel, that's the definition, but they have a different y-intercept. All right, and that should make sense. The y-intercept in this case is right here, and the y-intercept in this case is down there. So something to keep in mind, okay? Just take some time, see if that makes sense to you. Finally, many solutions. Well, in this case, again, there's one line. We can say that this is our blue line, and literally right on top of that line with the exact same equation is our second line. So they're always crossing. You know, you have unlimited solutions. You have what's called like infinite solutions because any of these points would be points where they would cross. So in this case, this is called dependent, if it ever comes up. There is no unique solution. No unique solution. The lines have the same slope and the same y-intercept. Okay? Same slope, same y-intercept. They're basically the same line. Okay, so just different ways to look at the possibilities for lines. Essentially, these are our three big cases. There's only three possible cases. So the first case, the second case, and the third case. You might want to write that down. So let's go ahead and solve some systems using these methods. Now again, you can solve these using any way you want. It says solve the system by graphing. Now there's multiple ways to do graphing, but you can say use any method to graph. I prefer the slope-intercept form, so you'll see that soon. All right, and we have two cases. Well, our first line, y equals negative x minus 4, in this case we know that our slope is negative 1, and our y-intercept is negative 4. All right, let me label these. This is our slope, and this is our y-intercept, or our y value of the y-intercept. You can say 0 and negative 4. So just based on that information, we can draw that line. So I would start with, think of it this way. You start with this line, you should pick out the y-intercept and then go from there to use the slope. The y-intercept of this line is negative 4. Let me just color this. I'll call this a blue line, light blue. That's our y-intercept. And then our slope is negative 1. So to be specific, you can say it's negative 1 over 1. Which means negative 1 means go down, and 1 means go to the right. Or you can say it's up and left. Okay? Because we can switch this up. I'll show you what I mean in a second. So let's look at this point here. We can go one down, one right. One down, one right would give me this line, but that's kind of a problem. I don't have anywhere else to go. So I'm going to kind of go backwards and go one up, one left. which gives me the exact same pattern, and now I can start filling in my lines, or fill in my points, which will give me the line. So I'll make the line on this. All right, this is the line negative x minus 4. All right, you would do well to write that down on the graph, because if you don't write it on the graph, you might mix up which line's which. So that's our first line. Let's do the exact same thing for our second line. I'll make the second line purple. Y equals negative, sorry, not negative, 1 over 2 x minus 1. So let's follow the same procedure. What I did was I noted that the slope was 1/2. That's going to give me up 1 over 1, up 1 right, up 1 right 2. And I'm also going to note the position of the y-intercept, which is negative 1. So right away, I know that my y-intercept is at negative 1. Sorry, the y value of the y-intercept is at negative 1. So I could write it again. It's actually 0, negative 1 is the point itself. And then using my slope, go from there. So this means, this slope means up 1, right 2. So I go up 1, right 2. I can find a second point. If I play the same game again, up 1 over 2, I get this point. And that's plenty. You actually only would need to do it once in order to get your graph. So let's see if I can do that. Okay, I'll say that these go on forever if I needed to. The line I just drew was y equals 1 over 2 x minus 1. And where do they cross? You know, where are these graphs crossing right now? I can see that they're crossing right here. So that's a really, really, really important point. They cross at the point, read it off. X value is what? Negative 2. And the y value is also negative 2. So they cross at negative 2 and 2. So to be clear here, let me just clean this up a little bit. Say the solution is negative 2 and negative 2. Or we could also read it out as x equals negative 2, y equals negative 2. Our final step is to check that our answer is okay. And remember, we're going to use the original formulas to check. So I'm going to take formula 1, or line 1, y equals negative x minus 4, and put our numbers in. That would mean that negative 2 is negative 2 minus 4. Let me just move this over here. And let's just check to see that the left side equals to the right side, okay? Negative 2 equals, negative 2 is 2, 2 minus 4 is negative 2. They work out. I can do the exact same thing for the other line, and I should do the same thing for the other line. So once again, I got to clean this up. I'm sorry I didn't think I had quite enough, which is kind of my my weakness. Again, this was the first line. I'll check the second line, y equals 1/2 x minus 1, putting my solution in for y and x. That means negative 2 equals 1 over 2 negative x minus 1, and let's see if both sides equal to each other. Well, negative 2, and if you work out the right side, it also equals negative 2. So it turns out that this side is fine. We've got the answer. Let's move on to the next example here. So I recommend that you pause the video here and try to do this question yourself, because you're only going to get better at this if you try it yourself. I'll do it for you, of course, but you should always check your work. So let's start with the first one. This is our line. It's kind of in an ugly form. We have a choice right now. We could either get the x and the y-intercept of each and solve, or we could put it into slope-intercept form. I'm just going to solve it for y. Okay, I'm going to go ahead and solve this for y. And the reason I want to do that is it'll give me slope-intercept form. So I move the x term to the other side. I'm going to divide both sides by 4. Negative 2x. I'm going to divide that by 4. And divide 16 by 4. It gives me 4. All right, I've divided everything by 4 there. That line, I don't need to write down slope and y-intercept here. I can read it right off, okay? I can read it directly from what I see. I know that this is my y-intercepts point, and I know that this is going to be my slope. I'm going to go down 2 and over 4. Down 2 and right 4. This is my other point. Okay, I only need 2 points. I don't need anything else to draw that line, so I'm going to go ahead and draw that now. So I kind of messed up that line. It's not quite where it needs to be, but maybe that's good enough. As long as the answer is clear, it's not a big deal. So this line came from this original formula. So just to keep things kind of in the original notation, you should probably write that. Again, this is the formula, this is the relationship of the line that gave us this. So that's why I'm going ahead and writing it as our line, just to keep track of it. You could write this on the graph, it's fine, it's no big deal. Let's do the next one. Once again, the next one is not in kind of a nice form. It is, but it's not in y-intercept form, and I just want to get some practice with that. So once again, I'm going to solve it for y. So that's going to be negative x plus 4. I brought the x over, and I need to divide everything by 2. Which means it's negative 1x over 2, also known as negative 1 over 2x, and then 4 over 2, which is 2. Again, I'm just dividing everything by this 2 here. And now again, I can very easily, or at least fairly easily, write down, okay, that's my y-intercept, the y value of the y-intercept, and my slope is down 1, right 2. So go down 1, go right 2. This should be my next point here. And once again, I can draw a line. Let's see if I can do a bit better job this time. I think that's probably best. It can be a little tricky to do this on the computer. So if you've got, you know, a more steady hand, it might be a good idea to just make sure you're careful. All right, that's actually better. In the first line, it doesn't look parallel, and I know they must be parallel actually. So I'm going to redraw this other line. I just saw a problem. Maybe you already noticed this when we were already screaming at the screen. This line here, this is down 2 and right 4. I only went 3. 1, 2, 3. So sorry about that. I didn't mean to throw you off there. That was not an intentional mistake. Let's draw that now. Okay, that's better. I guess I was being a little bit too, I don't know, I wasn't being cautious enough with that one. And let's label the second line, just so we have everything fully done. The second line is x plus 2y equals 4. And what you'll notice here, hopefully notice, is that these lines are parallel. They have the same slope. So there's no solution. We can't solve for x and y. The reason is the lines are parallel. And the important thing is, of course, the biggest piece here is the same slope. How do I know they have the same slope? Well, I can just double check it here. I can show you. Let's just take a look at the slope. Here, negative 2 over 4. Here, negative 1 over 4. Well, if we just simplify this one, divide everything by 2, we see that negative 1 over 2 is the next one. These are the same. Simplify this one up here, and it's going to give you negative 1 over 2. So it means that they have the exact same slope. So that's why I said they have the same slope. Same slope means they're parallel. So all these things kind of get wrapped up into each other. One doesn't necessarily come before the other. You just need to understand how it works. Okay. So the only other case we didn't do here was the kind of line on top of line situation. So that's how you solve systems of equations by graphing. Let's do systems of equations, or at least linear equations, using the substitution method, which is kind of like method 2 of the list that I showed you earlier. And once again, we have a handy list of steps here that we're going to follow. You should use this as a reference until you start to get this stuck in your head real nice and tightly. So first we're going to solve one equation for one of the unknowns. It's extremely important, okay? The first step is always the most important step for this one. Choose your equation carefully to make less work for yourself. And you'll see what I mean by that in a minute. You have a lot of choice as to which equation you start with, but sometimes there's a better choice. So substitute the resulting expression into the other equation. Solve this equation for the other unknown. Substitute this value into one of the original equations, check your answer. So this is all well and good to have these steps, but it doesn't really make any sense until we've actually done a question. So let's do this question. First things first, solve it by substitution. And the first step is to solve one equation for one unknown. Well, let's just look at this. Do you see one of these variables that would be easier to solve for? Like if we look at the first equation here, which variable would be easiest to solve for? It would be x. X is the easiest to solve for because it doesn't have a coefficient on it. If we looked at the second equation, both of these have coefficients, so there is no better choice. But this first x is really easy to get to. And again, we want to solve for one of them, the x or the y. So I'm going to go ahead and solve for that x. That's our first step. So write down x minus 3y equals 6. I'm kind of using equation 1 here, if you can think about it that way. And then the solve for x is as easy as putting the 3y to the other side. So that's our first step. Okay, it said here solve one equation for one of the unknowns. I've solved for x. Second step, substitute the resulting expression into the other equation. All right, so substitute what I have into the other equation. Well, my other equation is 2x plus 3y equals 3, but I know that x is this. So I'm going to replace it. That means 2 times 6 plus 3y. Plus 3y equals 3. And let's work that out. Let's see what it gives. 2 times 6 and 2 times 3, that's 12. And 6y. I'm going to group the common terms of the y's on the left. That gives me 9y. Bring the 12 over to the other side. You get a negative 9. And solve that for y, dividing both sides by 9. You get negative 1. And now we have one of our answers. We'll put it in pencil. Okay, one of our part of the solution. We found our y. How do we get our next piece of the puzzle? Well, how do we go back and solve for the next piece of information, which is the x? It says solve, well, I guess I did 2 and 3. Okay. The second step is substitute the resulting expression to the other equation. Solve this equation for the unknown. So it's now solved for the unknown. My fourth step is to substitute the value that I just found into one of the original equations. All right. Well, I'm going to go ahead and say I should put this into this equation because it's easy. If I use that equation, once it's solved, this whole right side is going to pop out this answer for x. So it's already solved for. It's really nice and easy to solve for, okay? So once I do that, I'm going to go over here. So 6 plus 3 times y. I know that y is negative 1. So this is the same as saying 6 minus 3, or in other words, x equals 3. And I am done. My solution is complete. My solution is 3 and negative 1. X equals 3, y equals negative 1, okay? That's the final answer here. That's my solution. So the fifth step would be to check my answer. I'm going to check it. How do I check it? I need to put my numbers into each equation and make sure that it matches. Okay, so my first equation, x minus 3y. X minus 3y. What does that give me? It gives me 3 minus 3y, y being negative 1. What does that give me? That gives 6. It's correct. I worked it out. what am I going to do for my other check? You know, take a moment to think about this. How do I check it? Take my second equation, 2x plus 3y, put x and y in. See if it gives me 3. This gives 6. This gives -3. 6 minus 3 gives 3. That's exactly what it said in the beginning. So my answer checks out. It has one solution, and that solution is 3 and -1. I'm going to go in Desmos and do this exact same thing. I'm going to check my answer with Desmos, and you should do the same. So just go to desmos.com or get it up on your phone. You can just get the app Desmos. No real good reason why you shouldn't do this for yourself. The more times that you see a solution from a different angle, the better you're going to get at it. So this is x minus 3y equals 6. This is the equation I was given in the first place, okay? X minus 3y equals 6. I'm just graphing it. That's what it looks like. Okay, great. But what's really powerful is graphing the other one as well on the same set of axes. So 2x plus 3y equals 3. And what is our solution? Do you remember what we said our solution was supposed to be? It's 3 and -1. In other words, these lines, this green line and this purple line, should cross when x is 3 and y is -1. And it does. So even before I started, I could have looked ahead and saw what the answer is supposed to be, and then did my substitution method to prove that it is true. All right? So take advantage of all the tools at your disposal to try and make sense of this, and it will get easier. I promise it's going to get easier. This is actually the last topic. We don't have anything else to cover today in this video. I'm just going to be doing more examples. So the next page has, I believe, 2 more examples, and that's what we'll do for the rest of the video. So what I'd recommend you do is try these yourself first and check your work against mine, okay? Well, I'll put the answers up here so they have something to check against. So the first one, that would be your answers. For the second one, it turns out there's actually going to be no solution. There's no solution for that one. And try to think, why would there not be a solution? In what case could you have 2 lines and there's no solution? We've covered it already in this video. It's a good idea to try and test yourself and say, how could I possibly have no solution? Once you have thought about it, that must mean that we have, remember, the same slope, but different y-intercepts. And another word for that is that they're parallel. Okay. So the rest of the video is going to be me working out these questions, and I recommend that you try them along with me. So I won't show quite as many steps this time. I'm going to follow the same steps, but not as many workings. So in this case, I see that to solve for v would be very simple. You could solve for literally any letter here. You could solve for r for the first equation. You could solve for any of these. And I literally mean you could go ahead and solve for any of these letters, and they would all give you the correct answer as long as you were careful. But this v is the clever choice. It's the smarter choice. It's the better choice. Take a look at the second equation. Let's rearrange that for v. And here we have it. We're going to take that variable. Do you remember what we need to do next? We need to take it and replace it into the first equation. What we're going to do is we're going to substitute it into the first equation. That's why it's called the substitution method. Substitute this into equation 1. You know, if this was equation 1 and this is equation 2, we're going to substitute it into equation 1. 4r minus 3v equals -8. I didn't need to write this step. You could leave it out, but I want you to be clear where everything's coming from. So 4r minus 3v. Well, v is this. So let's replace the v. This equals -8. Let's work it out. Let's distribute it, open the brackets. And notice that it's a negative times a negative here, so we get a positive 18r. This gives us on the left 22r. If we bring the 18 to the other side, we get a 10. Divide both sides by 22, you end up with 10 over 22. There's another way you could represent this. You should simplify it to say that r equals 5 over 11. Because if you divide both by 2, Some students I found had a little bit of an issue with this when I did it before in class. Sorry, I'm just trying to space this out. That simplification, if you don't have a calculator that does it automatically, it just means we can divide the top by 2 and divide the bottom by 2, and it would simplify out. Another way to write that is in your head, think, okay, divide the top by 2, that gives you 5. Divide the bottom by 2, that gives you 11. If you find that you're having trouble with things looking cramped, you can put the 5 and the 11 over on this side. Maybe that's better. There's no best way, really. And that gives us our final answer. Now we're not done. Notice that we've only solved for r. We need to solve for r and v. So how are we going to solve for v? You need to take this answer and substitute it into one of the previous equations. You can either put it into this equation, you could put it into this equation, or you could even put it into the first equation. I'm going to choose to put it into this equation here, and maybe you'll know why. It's because it's already solved for v. It's extremely important that you notice that, because it'll make your life a whole lot easier if you do. So v equals 6 minus 6r. I'm just going to go ahead and put the r in, because I know what it is now. It's 5 over 11. And if you divide that, or if you, work that out, this is 6. What's 6 times 5 divided by 11? Well, that's 30 divided by 11. And you can get common denominators or whatever like that, but your calculator should be able to do it. If you don't know how, please just let me know, and I'll show you how your calculator can do that work for you. But your answer is finished here. So the solution, in this case, if we say that r is x and v is y, I guess, we could write down the solution is 5 over 11 and 36 over 11. If you want to put decimals for this answer, that's okay too. Notice that this would be our r, this would be our v. It's not clear which one's x and y, or r and v, which order, so it's okay. And the decimals for this would be 0.4545454 for the first one, and the next one would be 3.27272727. So the fractions are better. I'm going to leave the check to you. You should be able to check that that's correct. And if I was to ask you on a test, for example, to check your work, just make sure you can do that, okay? The next one and the last one. Solve the following system by substitution. Once again, take a good look at what you start with and make a really smart choice where you're going to start, okay? I noticed that there's no coefficient in front of this x. So that is really the best place to start. If you start anywhere else, you're going to end up doing more work. All right? I'm going to rearrange that first equation for x. It's very simple. Just looks like this, okay? I'm going to take that and replace it into my second equation. I'm going to substitute it into equation 2. So if this is my equation, I'm going to say 3 times x plus 15y equals 10. By the way, I've taken this second equation, I'm just replacing x in that equation, okay? Maybe I should just fill that out just a little more. I'm a little afraid that I skipped too many steps there. Substitute this x, into the other equation. You don't need to label it as equation 1 or equation 2. You can just call it the other equation. What you'll notice, if you accidentally put this back into the first equation, it doesn't get you anywhere. So if you want to give it a shot, you can try that. Let's distribute this out and see what we get. This is an interesting conundrum. Look what happens. Negative 15y cancels with positive 15y. They cancel out and give 0. So the left side here, negative 9 equals 10? I mean, this is not possible. Negative 9 can't equal 10. So I'd say, therefore, there's no solution. These lines must be parallel. We don't need to... I assume it's parallel or it's some other weird case, but at the end of the day, the important thing is that there's no solution. So the last thing I'll do is I'm going to take these two answers that I found, I'm going to graph them on Desmos to prove to you that our answers are correct. So here we are again back in Desmos. I'm going to do the second example there first. So 4r minus 3v equals negative 8. It doesn't like that by the looks of it. It only supports equations of x and y, so I'll just call my rx my vy. That's okay. Shouldn't worry. 6r plus v, 6x plus y equals 6. These are my two lines. Do we remember what the answer was? 0.455, 3.273. That is exactly what I said that we'd get for these two fractional answers. So Desmos deals in decimals, but that's our answer. 5 over 11 is 0.455, and 36 over 11 is 3.273. So we're good. The next solution, or at least lack of solution, let's do the second one. That was one of our lines, and the next line was 3x plus 15y equals 10. Whew! All right, what's going on here? Notice I said that there's no solution for this next case, right? Not possible. I'm graphing these two. It says no solution, not possible. Notice that they have different y-intercepts, but they seem to be parallel. What that means is that they'll never cross. And what I love about Desmos is that we can just zoom out. We can keep zooming out. Notice that the scale is getting bigger and bigger and bigger. Like this is 15. What if I zoom all the way out and make these tiny, tiny, tiny? Well, they never cross. They'll look like they become the same line eventually, but these are not crossing. And I could zoom out until the end of time, like zoom out into space here, and they're actually never crossing. So it means that they have different y-intercepts, but the slopes are equal. All right. And if we wanted to double check that the slopes are equal, just as a little check, a little side note here, why no solution? Well, we can see they have different y-intercepts. Let's just rearrange them. If we rearrange this, we get 5y equals negative x minus 3. Divide both sides by 5, we get negative 1 over 5x minus 3 over 5. This is my slope. This is my y-intercept. Okay, let's see if the answer for the other one, this is our first case, let's see if our second equation gives us the same slope and a different y-intercept. So solve it for y. That means 15y equals negative 3x plus 10. Divide both sides by 15. I'm going to move this over because I'm going to end up writing over the page number. This is negative 3 over 15x plus 10 over 15. If we simplify that, the slope here is negative 1 over 5x. If we simplify this, divide both of these by 5, we get 2 over 3. And I hope you can see what I'm talking about. Same slope, different y-intercept. And I'll leave you with that. I hope that this video made some sense to you. If it didn't, please don't hesitate to contact me. I'm here for you, of course. And that's it. What we did today was we solved our systems of equations using graphing methods and substitution methods, and hopefully you can see how all these things are connected. I'll see you in the next video, or I'll see you in class, and I hope you have a great day.